विंसेंट आना सही यार। विंसेंट वर्सेस राइस्टर जनन ओके विंसेंट ओह विंसेंट जन ಗೆಲ್ಲರ್ ನೋಡಿ ಅಂತ ಹೊಡಿಯ ಚಾನ್ಸ್ ಕೊಡಲ್ಲ
Hello. Hello. Am I audible?
Yes, sir.
Yes, sir, you are audible.
Yes, sir. Yes, sir.
Yes, sir.
You're audible, sir.
Yes, sir.
Okay. One second.
Yes, sir.
Okay. I think I'll not use this. Just use the microphone from the system itself.
Fine.
Okay. Yeah. Thank you, host. And then I'm going to start and continue rather from where I have stopped yesterday. Okay. Sorry, there is some problem. Video I'm not able to activate, so my picture will not be available. So you have to go bear for today. I'm sorry for that. Then audio I think is clear, so we will go ahead and start. So yesterday we have heard some terminologies like program. Program, we have seen what it contains. It's a sequence of steps which are understood by the reader. If it is a natural spoken language program, like what we prepare, and then what is a machine program for a machine, that will be a high-level language program like C or Python or something like that. Okay, and based on the instructions that we send, there will be action taken by the system. And then the natural languages and computer languages, there are two types of languages, and almost all the computer languages are based on the natural languages only. So the syntax, what we call the grammar, the semantics, the meaning attributed or meaning provided by the program or by the system, right? So then every language, as you know, we have characters, the words, the punctuation marks, there will be action taken by the system. And then the natural echo, there are two types of languages, and almost all the computer languages are based on the natural languages. So the syntax, what we call the grammar, okay, I think there is some echo. I don't know how to do that. Host, can you help us? If I have to do something, I'm ready to do. Okay, all computer languages will follow the natural language patterns as a way. So till this point we had seen, and now let us go to next slide. All right. And a program.
The PPT is not.
Sir, you didn't share the screen yet, sir.
Sir, you're not presenting anything, sir.
Sir, you cancel the screen sharing.
Yes, sir.
Hello?
Slides
Yes,
are
sir.
not visible.
Sir, the
Yes, sir,
screen.
you're not presenting anything. Sir, it's not visible at all, sir.
Sharing their
One
screen.
minute. Just give me a minute. Window. This is the window I'm sharing. Now, please tell me, am I sharing
Now
this?
it became
Yes, sir.
visible.
Yes, sir. Yes, sir. It's visible right
Now
now.
it became clear.
Okay,
Yes, sir.
I will go to presentation mode so that it will be more clear. Is it fine now?
Yes,
Yes,
sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
Okay.
Shall I go ahead?
Yes,
Yeah.
sir.
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay. Yeah. Thank you. Maybe you can mute your speakers so that it will not disturb or no, there will be no echo or anything of that sort. This is a request from my side. Okay. Yeah.
Yes.
Program, as you know, will have a set of instructions or a command group or command set. And then what it will do, whenever you write a program, it is for specific project, specific purpose, specific application. That's why we call it an application-based project or application-based program. Then what it will do? For example, it is a billing system in a hospital or a billing system in a restaurant, or it can be your road transportation corporation or airlines reservation, or it can be the salaries slip generation or the salary maintenance of an organization or a college, or even the record maintenance of the students in a university or in a class or whatever is that. So all such things are various applications, and we divide fairly the applications into two types. One is the commercial application, where it generates the revenue, it generates the money. So it can be like your RTC booking or airline booking or something like that, or even hotel billing, etc. And another one we call as technical application or engineering application, where there will be a lot of technical activities that are being done, that are being performed. Various formulas are used, and then you perform a lot of computations, a lot of calculations, and data manipulation or data handling we call, or the information handling. So that second part, always commands and data will work together. They have to work in unison. A command is an instruction which instructs the computer, please do this, do this, do this, do like this, provide me this output, or compute like this, use this formula, you calculate this, and then give me this output. This sort of instructions it will give. But to act on, you need data. So that data is nothing but the information that we feeding. Okay. So then, before we attempt any project or any program or anything, even simplest of this, for example, you have two numbers, you want to find out the sum of the two numbers. It's a very simple thing. First, you need the two numbers, and your normal program. What you do is, please read the two numbers from so and so. The numbers are available in such and such place or such and such area. So you read those two numbers and assign them to the two different variables, and then add them and assign the value, the outcome of that addition to a variable called sum or something like that. And then you have to print it so that it will be understood by the reader. So that means to say, normally a set of commands will work on a set of data, and sometimes the program will be little simpler. The complexity of the data will be too huge. Like for example, the rockets when they are working, and then every moment, every second, or even a fraction of a second, you need to compute hundreds and hundreds of parameters of the various subsystems that are working there. I'm hearing some noise, background noise. I request the people to just be little silent or put in a speaker in off mode so that it will not be echoed onto the system. Please. Yeah, thank you. So then the rocket subsystems can be it the power subsystem, or it can be telemetry, or it can be telecommand, or it can be sensors, or it can be various types of command systems. All such things have to work in unison within fraction of a second. They they should get all the data, like what is the temperature, what is the pressure, what is the fluid pressure, what is the fluid flow, whether what is the quantity, and then what is the pressure generated, etc. All those things, and then keep monitoring with respect to a record. I mean, the reference value. So, or rather the set values. So if anything is going beyond the range, then it has to do a mid-course correction. So that is how they normally the rockets are designed, developed, and they are executed. As you know, a rocket will start from a launch pad, take a satellite as its payload, and then start moving into space, and then keep traveling thousands of kilometers before that is launched, and it will go to an altitude of close to 700 to 1000 kilometers, or sometimes even more. And during its entire path, whatever parabolic path it takes initially, and then slowly it slows down, and then finally injects the satellite into orbit. So this much activity, very complex function, and there are n number of data variables which will be available, and you need to handle all those data, manipulate all those data properly. So for that, a detailed analysis of the problem solving has to be done before we execute anything. So for that, what normally is done, simple programs, yes, it's easy. You write an algorithm, and then you make a small flow chart of that, and then choose the language what you want to use, maybe C or Fortran or Basic or Visual Basic or Python or Pascal or whichever language you want, or even an assembly language for that matter to some extent. Or there can be an assembly part can be in assembly and part can be in high level language. So majority of the initial observations can be there on the in the high level language, and very niche programs, very specific programs which can be there in the assembly language, and then they have to be interfaced after compiling, and there you assemble, generate an object code, and here you compile and get an object code, link them together and make an executable file. So this is an art by itself, and for that one needs to know what is this algorithm, what is the flow chart, and actual program. And those of you who have come from say PCMC with the computer as one of the language, so you would have heard these words and used and you have written yourself a lot of algorithms, flow charts, and actual programs. I'm not dwelling into too many details, because when the actual program for your university thing starts after 18th of October. So at that time, these things will be dealt in detail. I'm just trying to give you a flavor of what is programming, and then how you have to write programs, a couple of examples, and how to handle the data, how to handle the commands, etc. And I have taken C as one of the language, being the popular language. Okay, so this algorithm word has come from a Middle East scientist. He was a mathematician called Al-Khwarizmi. He initiated, or rather he proposed, that before you solve the problem, please note down, jot down all the steps that you want to do in a chronological order. And there is no specific language requirement. It can be like a small PPT with bullet points. Even that is also fine. Means what step should be done first, what should be done next, what should be done next, and then are there any loops, are there any while loops or for loops or something like that, a repetitive type of activities, and there are some output activities, some processing activities, some computation activities. All those steps have to be very clearly and without any problem have to be noted down, because you know computer is a machine. It will not interpret, it will not, until unless you tell, it will not use its past things and try to incorporate the things. So you must and should tell each and every step very clearly. Don't expect the computer, okay, if you give two numbers and ask it to compute the sum, it will display by itself the sum. No, you have to tell specifically, yes, I am giving you these two numbers, read them, then compute the sum and print the sum. So then, and then stop. So like that, it will tell you. This is what you need to understand. This is a very clear thing. And then flowchart, basically there are various types of processes. One is called the input process. A process is like a step, you can just imagine a work, a job, a task, you can say, right? So in that input process, you will get you'll make the computer to read the inputs from its input unit, like it can be a keyboard or a mouse or joystick or some such thing, or it can be touch sensitive screens nowadays on many of your mobile phones. So these will become the input units, and through which the data is read into the computer. And then the actual process, like central processing unit, there is a set of data available, but what to do with the data? All right. So who has to do, what to do, and where it has to do. So you have a lot of arithmetic activities, you have a lot of logical activities. Let us understand in a short while what are those arithmetic and logic things shortly. And there is a lot of data to be crunched and converted from one form to another form. You have to use a lot of formulas and then do calculations, etc., etc. So this entire thing is called the processing, the arithmetic processing or logical processing, or you'll call it as AL processing. And there can be another process will be the output process. Now you have all the data read, you computed it, calculated it, and now you need to communicate it back to the external world. Until and unless it is communicated back, it will not be helpful. Like your teachers will teach you, and then you go back home, prepare your assignments, you make your homework ready, process records, everything you will finish. But don't come to exam and write the exam. So who will give you the results? Like that, you just imagine and have a comparison between cybernetics thing, like again human being versus machines. Then comes the actual program, and this flowchart will have mainly three steps, right? One is input, process, and output. And in process, there can be some decisions also. And there are various types of boxes which are used. I have not mentioned here, but it will be covered as part of the programming language like Python, which university is thinking to give it to you this year. So in Python, I will cover those things. Then actual program is the specific language which you are using, and you need to follow that. It's a syntax and various commands that are required. You need to understand and use them efficiently, and then the program will be written. The actual program will be written for computer to perform. Okay, so these special flow blocks, what I mentioned, I'll just name few, like start and stop will be identified with an elliptic shape thing. And the rectangular shape is used for the process, like predefined process or arithmetic process or logical process, etc. And mainly the logical or decision things will be using a rhombus kind of structure or rhombus kind of picture. And then input and output will be using like parallelogram kind of box. Okay, then we are going to study here some of the C programs, and then some small history about C language. During the 70s and 80s, they were developing another operating system called Unix. Earlier, it's like a unified system basically. Earlier, IBM had its own, and many of the other computer companies had their own operating system, and they were very specific. Okay, and no change, no portability in the sense I can't use it on any other machine, any other computer. So then the people were thinking, why can't we make it a unification of that and try to give a generic thing so that people can make use on different platforms or different computer systems. That was the idea. And when the Unix operating system was getting written, Ritchie and Kernighan generated or developed the C language. And prior to this, there was a language called A programming language, or APL, or in short, A. And then they improved upon and generate a basic computer programming language that's called BCPL, or in short, it is referred as B. So after A, B. Now, final improvised version when they developed with the proper structuring for writing the Unix operating system, and that they call it as improvised version as C. Okay, so now this we have already seen in the sense the mostly I don't know whether it was studied in your SSLC or PU1 or 2, the binary arithmetic. It's just a simple, I'm just covering in a couple of minutes. So binary arithmetic, it has two digits called binary system has got 0 and 1. As you know, it is a base 2, right? And the standard one which we use is base 10, or decimal system, where you have the decimal digits from 0 to 9, and here you have 0 and 1, only two numbers, and these are easy to get represented in any digital logic. Earlier systems, I'll just slightly brief here, digital and analog. Analog is linear or continuous signal. In electronic systems, when you need power. Any active device you take from transistor onwards, transistor and IC or any of the devices, microprocessor, FPGA, ASIC, or anything you name, they need power, right? So when power is given, it will be a DC 5 volts earlier, then it is reduced to 3.3 volts. Now most of the chips are operating between 1 to 1.5 volts. Okay, a DC voltage is given, and then between 0 to like 0.2 volts or 0.15 volts or something like that, that level around 0, it is called as logic level 0, or digit 0, or binary digit 0, or bit 0, or low level. And when it goes close to power supply, plus minus some small value delta, like 3.3 volts, if you take 3.3 volts, 3 to 3.6 volts range, if any signal is there, that will be treated as logic high or logic 1. Okay.
Excuse me, sir. You
Hello?
have to change the slide.
Pardon me?
So you haven't changed the slide to binary arithmetic.
Not
It's still
changed?
in the no, it's still in the previous slide.
One minute. Now you just check. Is it refreshing?
No, sir.
No, sir.
No, sir.
No, sir. It's the same.
Same slide?
No, sir.
One of you can answer. Is it the same slide being shown there?
No,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
Refresh now,
It's
right?
still in slide 11. You have to go to slide 12.
Now it is in slide 12, right?
No, sir. It's still
No,
in
sir. It's still in slide 11.
Still inside. Sir, I think the screen froze.
1 minute. Is there any internet loss? I doubt.
Sir, we are able to.
Change
It has changed.
So slide change.
Now is it different slide?
Now it's in
Yes, sir.
12, sir. Now it's in
It is
12.
12. Okay. Sorry. Maybe you just interfere in between as and when such things happen. Right. So sorry for that. I didn't knew. Thanks for reminding. Okay. Now you have the binary digit 0 and 1. That's what I was explaining. And let us see 1 byte. It is difficult to just work on two digits like 0 and 1 only. And you can represent maximum 0 as one level and 1 as another level. Only two values will be there. So now you want to represent more. You want to mention more. Then how do you do? Okay. So for that, people prefer to use multiple bits. One bit is one binary digit, either a 0 or 1. Now they grouped together a set of 8 bits and or 8 binary digits, a combination of 0000 and 0000 11111111. So that makes 0 to a high number like 255. Right, and I'll not get into how you need to convert that into 0 and 1 into the actual value, equivalent decimal value. I hope you know that. If it is not there, we can cover it sometime later also. I'll just try to repeat on this byte and the word, etc. 1 byte is 8 bits, and this 8 bits of data, if you have in a memory, assume the states like all 8 zeros and all 8 ones. So all 8 zeros, it is equivalent to 0, and all 8 ones when you have, so it will be like 2 power 8 or 2 power 8, 256, and minus 1 normally. Because all ones, if you take 1, then next will be double of that 2, double of that 4, then 8, 16, 32, 64, 128. You add all of
Sir,
these.
can you just hold on?
Hello.
Bro, unmute yourself.
Yeah, some noise is coming. Can I continue?
Yes, sir.
Okay, thank you. So 2 power 8 is 256 minus 1 approximately. Actually, 2 power 8 is 256, but the last value what you get is 255, and including the beginning number 0 to 255 is 256 numbers. So, or just to have a simple thing, I will explain orally itself. Suppose I have 2 digits or 2 bits, then it will be 00, 01, 10, 11. So 00 is 0, 01 is 1, 10 is 2, and 11 is 2 plus 1, 3. So 0 to 3, 4 states or 4 values. And 16-bit address lines for microprocessor can access 2 power 16 data values, or 2 power 16 memory locations, or 2 power 16 values. So 2 power 16, if you do, it will translate to 65,536 values. Okay. And then the present day processors, most of them, whether the PowerPC or similar to that, or Intel's Pentium and other kind of processors, what you see have got 32 or 64-bit address. So just imagine, for a 2 power 16, I was able to access 65,536 data values or addresses or different locations or memory values, I can say. But now for a 32, it will go to 2 power 32. So it is 2 power 16 into 2 power 16. So 65,536. This is called, actually, in case of decimal system, 1000 is called as 1K or 1000, like 1 kilogram or 1 kilometer or something like that. A kilo stands for 1000 in our decimal system. And in binary, the nearest one is after 256, that is 2 power 8. Next is 512, and next is 1024. So at 1024, which is 2 power 10, is nothing but the 1 kilo here, right? And this 65,536 divided by 1024, if you do, you will get 64K. So 64 kilobytes or bits, whatever it. So here we are taking a 16-bit address lines, and just imagine all 16 zeros and all 16 ones. So it will translate, it can read, the values will vary from 0, 1, 2, 3, 4, like that. If you keep on counting, it will come to 65,535 as the last value, and including 0, it will be 65,536 values, right? So the now just imagine 2 power 32, and when it has got 64-bit address, this is 2 power 64. It runs into millions and millions of memory locations which it can access. And for these things, the data also is huge. It will be close to 32 bits data if you take 2 power 32, which will be 4 million bytes or something like that. Okay. And in C, we use two different types of, or rather three different types of integers. One is called short integer, another is called normal integer, and the third one is called as long integer. You may be surprised. Integer is an integer which will run from minus infinity to plus infinity through zero, the natural number line. Okay. And why am I telling the short integer, long integer, etc. Right? So that is a question which even I had when I studied it for the first time. So here, what they have done is, sometimes to save the memory, because if everything is made to say a long integer so that you can handle the longest or the largest of the numbers, so then in such a case there will be a memory requirement, right? I will come to that number. Long integer, it is a 32 bits. That means you need a 32-bit memory area to store one long integer value. But your requirement, assume, is varying between something like 0 to 100 or 0 to 200. Those are the only values which you are going to store, nothing more than that, right? So then in such a case, you need not have to use a long integer of 32 bits. So you go for just a short integer of 8 bits. So in case of 8 bits, what they do is, they will take the 8 bits. The first, the rightmost bit is called as the least significant bit, or LSB. and the first bit in it is called as the MSB. So how does it matter? Rather, like how to represent or something like that. For example, I write 1 0 0 0 0, then 1 1 1 1. So how many digits I use? Binary digits 8, right? So the last four are 1 1 1 1. The first one is also 1, and in between 3 zeros are there. So when I translate this, it will be 1, next will be 2, then 4 8. So 1 2 4 8 will be 15, and the next 16 32 64, nothing is there. And then you have the first one is 1. Suppose you are handling unsigned values. I hope you know unsigned and assigned. Unsigned means all positive values only. There is no negative value in it. Whereas signed means you will be handling both positive as well as negative numbers. So if you are handling negative numbers as well as positive numbers, then some bit in it should be identified for representing the sign of the number. In decimal system, we write plus 22, minus 56, something like that, right? So it is easy to write here. But in case of computer languages and computer data representation, it is not that easy. So what we do is, suppose it is a 8 bits, then I will use the first bit for the sign. If it is a signed value I want to represent, I want to use. So then first will be 1, and then rest all will be values actually. So now how many will be left out? 7 will be left out. So then what maximum value I get or what minimum value I get, I need to see now, right? Suppose the first one is 0, right? That is a sign bit. 0 is represented as a positive number. 1 is represented as negative number. This is the nomenclature when the system followed in the system. So 0 followed by all zeros is plus 0, or rather 0 I can say. Then 0 followed by all ones. So that is 1, 2, 4, 8, 16, 32, and 64. So if I add up all those things, so 64 plus 32, 96, 94, 96 plus 16, 112, and then you just add another 15 to it. 112 plus 15 is 127. That is what I had written here as plus 127. Then if it is a negative number, then 1 will be used. 1 followed by all zeros, all ones. Like that, I will have a range. And that range, maximum number I can represent is minus 120, minimum rather, minus 128. And maximum negative number will be minus 1. Then I will have
Sir,
0.
I'm sorry, but are you gonna? Should you be in the next slide? I mean, it's a bit
No, I am there on
confusing.
slide number 12. Are you not able to see my slide 12?
Okay,
12
no,
is
sir.
a,
I just got confused. It's my fault. My bad.
Okay.
oh, sorry. Okay, no problem. Yeah, it happens because online, and then there's some system issue yesterday, and today only we are little lucky and then doing better. Okay, so like that, then this I will explain again in the next future classes. Don't worry, it's just a flavor I'm trying to give you. Okay, then you have an integer of 16 bits. If you take, the signed values will range from minus 32,768 to 32,000 plus 32,767. Because 2 power 16, as I have told, is 65,536. You just exactly divide this into 2, you will get 32,768 values, and minus 1 to minus 32,768 will be the half of negative values, and 0 to 32,767. So why I'm stressing here is in between there is a value 0 which we normally forget. For example, minus 10 to plus 9, if somebody asks you quickly how many values will be there, we forget 0 and then tell 19, right? It is actually 20. So say, and in binary it is much more, situation is much more critical here. So in case of an unsigned, that means no negative value, all will be positive, 0 to 65,535 values. And same way with the long integer 32 bits, you yourself can do 2 power 32. Otherwise, we will see it a little later. And float is another type of variable which we use in C language. and it is a 32-bit long. It's called single float or single precision float number, 32 bits. And these 32 bits are divided into two blocks. First is 8 bits of first byte, I can say, and next will be another 3 bytes, because one byte is 8 bits, so 32 bits will be 4 bytes. First byte will be for sign, and remaining 24 bits or 3 bytes will be for mantissa. So this is basically an exponential representation of the number, which I don't know whether you have studied it or not. We will see in detail during the actual class. And like the number is stored as x, e, y. E is for exponential. It can be written as just e, or you can write it as exp. Both are acceptable. X is the mantissa portion and y is the exponent portion. And here as an example, I have written 1.45 e 12. That means 1.45 into 10 power 12. Okay. Uh, just tell me whether you are seeing my next slide on 13, slide number 13. I have moved over. If it is not
No,
refreshing,
still on
sir.
slide number
Not
12.
No, sir.
Till 12,
No,
sir.
sir.
No,
No,
sir.
sir.
not yet, right? Okay.
No,
No,
sir.
sir.
Now we
No,
can
sir.
No, sir. Now we can see,
Yes,
sir.
sir.
Yes,
It's
sir.
moved, sir. Move, sir. Yes, sir. We go
Now
to the
it
next
moved,
slide.
right?
Yeah, sir.
13.
Yes,
Yes,
sir.
sir.
Yeah,
Yeah,
sir.
sir.
Yes, sir.
Okay,
Now we
thank
can
you.
see, sir.
Yeah.
The language, sir.
So then C language has very, what you call, well-structured language with well-defined data variables and data constants there, and various types of data. We'll just try to briefly touch upon before using them in a program. So constant, its value does not vary, whether it is a numerical value or character array or string. A string of characters, they can be numbers can be there in it, then character constants can be there in it, and then the punctuation marks can be there. This is called string. And variables, stored value varies based on some operations performed on it. We will see, and then these variables can be defined by using starting with any of the alphabets, and uppercase and lowercase alphabets will have different memory locations assigned. That means they are two different locations, they are two different variables, and they will hold two different values. For example, I will use n as a variable, n lowercase, n uppercase. So n lowercase and n uppercase in many other languages like Fortran, COBOL, etc., they are one and the same. But in case of C, the lowercase n is a different variable. It will occupy a different location, and uppercase n will occupy a different location. That means in the computer hardware memory area, what I am talking. And various types of data are there, like integer. Just now we saw single and double, like 2 bytes and 4 bytes, and short int also is there that I have briefed. Character is just a single byte. Okay, that means 1 byte, and it will vary from all 8 zeros to all 8 ones, and it is represented with a char or char, and the total number of values or the characters what you can get from this 1 byte is 0 to 255. And they are called the there is something called American Standard Code for Information Interchange, or ASCII, which you say ASCII we call, right? So ASCII is a standard which is used wherein there are some values assigned to them. Like for example, 65 ASCII value of 65 decimal, if you take, it is uppercase A, then 66 is B, then 67 is C, like that it goes on. And somewhere from 97 onwards, the lowercase a starts, then B, C, etc. will continue with that. And there are various characters. The ASCII 0 is called a null character. It is not at all defined character. It is null, we can call it. Okay. Then float, as I have told, a single and double precision floats. They occupy 4 memory locations and 8 memory locations, and the ranges, etc., we will see a little later. And Boolean, though this is using 1 byte, actually it uses any of the integer value only, short int or int, and it will hold a value of true or false. There is nothing like a Boolean type of data specifically defined in the data structure of C language, but it is used by using a integer variable. Then arrays are basically a group of data of the like type. like marks, names of the students, right? Or it can be temperature of a day, or it can be the rain that has happened in an year. So these are all a single unit, like it can be represented by some names of a similar type or other things. So they are all coming under what are known as arrays. And then the various complex structures, it becomes difficult. For example, I can't have 10 arrays, one for roll number of the student, then another array for name of the student, and another for the six subjects marks what he has got, then the total, the grade and the result. So like this, if I take one entire thing, it is called as a record in many of the commercial application, and here we call it as one structure. Okay, so it's a single structure I can use and access a heterogeneous type of data. And there are various input and output statements which we are going to use a little later. And I'm sorry. Host, can I continue for another 4 minutes? At 10:45, I would like to stop. Is it fine?
Okay, sir.
We have 10:45
sir.
another class, sir.
Yeah, 11 o'clock you have a different class, right?
So we
10
have
Yeah, sir.
chemistry.
From 10:45,
we
sir.
have class.
From 10:45.
10:45.
10:45. Okay. Then I'm sorry.
10:45, sir. 10:45.
Okay, no problem. So we will close here and we'll go ahead with some of the language commands and how to write a program and run them, etc. in the Monday's class. Okay, Monday we will be meeting at same time, 10 to 10:40 for 40 minutes. So we will try to make use of maximum use of it and try to get a flavor of computer language and how to write the commands, what are commands, what are data, and how to handle them, etc. In a nutshell, in just 3 days, I don't say that this is a total teaching. It's just showing you the flavor. Like when you go to a sweet shop, that guy gives you for tasting the sweet, right? So it is very similar to that I have given. Very sorry for that. But when we start the real class, at that time, we will dwell in detail on all these aspects. And there you will have better understanding and better knowledge on that. Okay. Thank you, friends, for patient listening, and we'll meet again on Monday.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir. Anything?
Thank you,
Thank you,
sir.
sir. Thank you,
Thank
sir.
you, sir.
Thank you, sir.
Thank you, sir.
Okay. Take care. Stay safe.
Thank you, sir.